Hello, everyone, and thank you very much for tuning into Paralus Community or Paralus Office Hour. And I am Saim Safdur, one of the core maintainer of the Paralus open source project. So today is June 8th and monthly Paralus community call happening. I have a wonderful guest with me today from another open source community. But let's set the agenda first. What we are covering today. So managing multiple Kubernetes cluster and federating access while maintaining robust RBAC practice is a complex is a complex task. With Kamaji, Kubernetes-in-Kubernetes approach and parallel centralized RBAC and authentication capabilities, organization can effectively manage their cluster, achieve audit logging, and implement advanced RBAC practice, ultimately leading to improved efficiency, security, and compliance. So, without further delay, I will straight go to Dario from Kamaji and Capsule Project to discuss what we are covering today. And first, Dario, can you introduce yourself a bit to people who
Sure,
wanted to
sure. Absolutely, yeah. Thanks for the awesome introduction, also because you were able to describe in a nutshell the challenges. So, my name is Dario. I'm working as open source developer and technical advisor at Classics, that is the commercial company behind Capsule and Kamaji. And Kamaji essentially was born due to my experience as site reliability engineer. So, I was managing a fleet of clusters and I was wondering why I have to repeat always the same task several times. And can we use a different approach in managing Kubernetes at scale? So in the end, I decided to open source my idea. I started contributing to the open source community, and here we are with Kamaji.
Yes, absolutely, absolutely. And today is a day to tell people because one of the challenges with the platform teams and the platform wave is giving these kind of the toil tasks like revoking permission, pre-configuring role across cluster, namespaces, projects, and more. And these clusters are geographically distributed in various different regions. And remember, the cluster is not on. I know some of the organization working on GKE, EKS, AKS, DigitalOcean, all you name it on the same time with different cluster management. Having a centralized visibility is important. RBAC simplification is not just a requirement, it's a prerequisite to be successful. Otherwise, your developers keep quarreling with each other. Who deleted my app? What happened to my app? Is it already been there last Friday, but I'm now Monday started? Is nowhere. Where can I find it? So that is a challenge that we need to address. So Dario, if you have some demos or if you have anything prepared for today, it's your time.
Sure.
I will ask question as we go. Up to you
I
now.
I'll start sharing my screen, so we should be there. Oh, yes, it's working. So I try to prepare some slides and also a demo. So I'll try to get through the slides as soon as fast as possible. So my name is Dario. I'm here presenting Kamaji, and I'm working as technical advisor at Classics. That, according to me, Classics is the leader in multi-tenancy solutions. So let's try to understand what is multi-tenancy. Essentially, it's like having your building, and in your building you have multiple tenants, so multiple apartments that you're renting. So it's pretty similar to what's happening in your infrastructure, because you got your bare metal servers, you got your EC2 instances on AWS, and then you have to deploy your tenants' workloads. So it's a common pattern we saw several times, especially with big organizations where they got 100 or 1,000 of developers and they need to ship their own applications to production. So in a nutshell, multi-tenancy is all about resource control and isolation. Obviously, we got multiple levels and I'd say multiple models of multi-tenancy. And each model has different shades of multi-tenancy. Keep in mind that, as same you were saying, we can have bare namespaces. So I'm referring to that as soft isolation. So it means that you're using a shared cluster where all the developers are entitled to create applications and manage these applications inside the boundaries of the namespaces, or maybe you need a harder isolation. So one cluster per tenant. It's something that is pretty common also considering the rise of platform engineering, because you want to focus just on delivering your applications. You don't want to deal with the underlying infrastructure anymore. You just need to focus on your dev life cycle. So let's try to talk here about the hard multi-tenancy, so with Kamaji. So what are the challenges when we're talking about multi-tenancy? Essentially, as I said before, you need your own dedicated API server. And you need to get dedicated node ports. You need to avoid noisy neighbors and higher storage isolation. So in the end, it means that you cannot use a shared infrastructure. So namespaces here cannot play a game. And it means that we are entering here with Kamaji. So keep in mind that I'm a geek, I'm a nerd, and one of my favorite anime movies is Spirited Away by Studio Ghibli. So with Adriano, that is the co-founder of Classics, we decided to pay a tribute to this spider demon that is preparing the hot water for the bathhouse. So it's a long story. So keep in mind that essentially Kamaji is providing control plane as a service. So essentially you're getting your own control plane without knowing what's going under the hoods. So let's try to understand in a nutshell the key features of Kamaji. It's not a sales pitch, but just to provide you a brief overview of what is Kamaji. So essentially you can use Kamaji to offer a self-service Kubernetes, and why it is different, and it's not a distribution. Pay attention, it's not distribution because Kamaji is offering upstream Kubernetes service. We are running the control plane components as pods in a management cluster, and it's much more cheaper compared to virtual machines, because we don't have to create our own virtual machines. We don't need to take care of the networking, the storage. We are running as pods. So the same principles that we saw with applications. So converting from bare applications running on virtual machines to containers, the same applies also for the control plane. So with that said, it means that we got the control plane that is running inside of a Kubernetes cluster as a regular application. Because if you think about the API server, we got an HTTP endpoint, and then we got a database that is etcd, it's a key value store, but you're getting the point. And essentially, it's like a regular application you're already hosting on your own Kubernetes cluster. And last but not least, also Kamaji allows to run multiple clusters, because we know that in the end, we cannot have a huge cluster. You want to decrease the blast radius. You need multiple clusters for many reasons. And essentially, Kamaji has been designed to run at scale. And with at scale, I'm referring to something like 8,000 of control planes and even more. So with that said, in the end, we are using a shared infrastructure. So we are always talking about multi-tenancy. But in the end, all the data is segregated in different data stores. So it means that what you can do is to have your own dedicated API server, but then the data is stored somewhere, or is shared at the, not at the infrastructure level, but rather at the application level. And last but not least, and I already said that essentially we are not running a distribution of Kubernetes. It's vanilla Kubernetes. It's CNCF compliant. Kamaji passed the Sonoboy test. So essentially, if you're going to use Kamaji, essentially it's the same effect you could have running your own managed Kubernetes solution, or rather EKS or AKS. So in a nutshell, let's try to understand the architecture. As I said before, we got our management cluster that we call admin cluster, and essentially we're ending up here with control planes that are regular pods. And these are worker nodes from different cloud providers. I could have AWS, vSphere, or OpenStack. It really depends. Keep in mind that Kamaji is essentially a sort of framework to build your own solution to offer managed Kubernetes service. So in the end, you can imagine that maybe I could have everything on vSphere because I'm running on-prem, or maybe on the cloud, so on AWS, and then each tenant account is bringing their own nodes from their organization. So with that said, you're creating a sort of accountability in regards to the cost. And also you're consuming the Kubernetes API server as a service, as a regular service. Obviously, We don't want to create a drop-in replacement with EKS, but it really depends. You can do whatever you want with Kamaji. So with that said, it means that the control plane is running as pods. So it means that we got this pod where the API server, controller manager, and kube scheduler as running as regular containers. And that's all essentially, because then we got the API server that is connecting with the multi-tenant data store. And there you can use etcd, PostgreSQL, and MySQL according to your needs. What you can do is to use one huge multi-tenant data store, or rather doing a sort of sharding. So for this customer, I'm creating one etcd. For another customer, one other etcd. So the reason behind that is that on Kubernetes, essentially running etcd is really painful, is the most critical task that you have to take care. The idea here is to say, let's try to share all the data that we have in common between customers or end users in one data store, so in one etcd. And with that said, we are decreasing also the operational burden, also because then we'll see that all the dull stuff in regards to generic certificates, kubeadm, Bootstrap is done by Kamaji. So with that said, we got some internals here. I will skip that because I prefer showing you a demo. So here we are. So this is kubectx. Let me change.
Dario, can you increase the font size of the terminal?
Absolutely. I'm just changing the context, and I have to find now the correct window. So keep in mind that this is the dashboard that we are going to open source. So this is the Kamaji dashboard where you can see the time control planes, and then we got also the data stores. So the data stores are the place where we are storing all the etcd data. For the sake of simplicity, I'm just referring to etcd. And then we got our tenant control planes that can be, as you can see here, placed in different namespaces. So you can imagine if I'm running a team, each team is going to have its own namespace, and in each namespace, the team can create their own control planes. Right now, I already created some control planes. So what I'm going to do is to create a new one. So let's say the name, let's go for Paralus. In the namespace, default, and just for the sake of simplicity, I'm keeping the default values here and removing some of them. So our Paralus tenant control plane would like to be exposed like a load balancer. And I'm going to use Steve's Kubernetes version. And since I want to let join real worker nodes, I'm using the systemd group file system driver, and I'm removing all this information. We don't need anything of this. Also the address, because it's going to be provided by the load balancer. And then we are keeping also the add-ons, so core DNS, kubeproxy, and connectivity. So as you can see here, it's all declarative, so we don't need any imperative command. And that's really cool because in the end, with Kamaji, the control planes, the time control planes are already GitOps ready. You can apply that using FluxCD, ArgoCD, or whatever you want. So now I just need to click on this button, create. And as you can see here, in a matter of seconds, we should enter in the status provisioning. We are waiting for the IP from the management cluster. So as you can see here, we are in the provisioning state. And in a matter of seconds, Kamaji will take care of creating the CA, the API server certificate, the kubelet certificate, and so on and so forth. A lot of information. And trust me, it should take just a few seconds, but yeah, it's ready, as you can see here. So Paralus is ready in 30 seconds, a fully compliant cluster. Just to show you what's going on here, you can see that we got several pods because we decided to go for 2 replicas. And we got our deployment, that is the deployment providing these pods. We got our service, that is a load balancer, and then we got multiple secrets. So we got the admin kube config to interact with the cluster, the API server certificate, the API server kubelet client certificate, the CA controller manager kube config, data source certificate. So a lot of stuff that obviously you can think about what happens if I have to do that manually. it will take hours doing that. Instead with Kamaji, essentially it takes just 30 seconds according obviously to the underlying infrastructure. And if I delete something, if I try to misconfigure the control plane, essentially this is an operator, and the operator is reconfiguring everything according to our needs. So now, just to show you that it's working, I'm viewing the kubeconfig. So I am the platform administrator, and I'm downloading this kubeconfig. And what I can do is to create a Paralus kubeconfig file. I'm placing that here and using kubeconfig Paralus kubeconfig kubectl get nodes. Here we are. No nodes. Why that? Well, it's not a bug, it's a feature because it's like EKS and AKS. So it means that control plane is totally hidden, so it's not managed. But keep in mind that if we take a look to the namespace, you can see here that is a regular Kubernetes cluster and also the version. So we are running 1.25.2. What we could do maybe is to say, okay, I want to update the control plane. So I need to change the version that I see that I can edit where. Here, switching to 26.0 and I update that. We are seeing that the control plane is entering in the upgrading phases. So what I can do is to issue watch -n. So please give me the Kubernetes version. And as you can see here, the upgrade was totally smooth. So no downtime. Why it is? Because we are running as pods. So essentially it means that we can easily simplify the management of the life cycle of clusters. So we got the control plane, and keep in mind, this was one of the most challenging stuff to manage. But obviously, we want to see also the nodes, because otherwise, if we don't have nodes, how can we deploy applications? Right now in the dashboard, we are supporting the creation of several node pools on AWS, but keep in mind that Kamaji has been designed to run based on the kubeadm bootstraps. So you can use whatever you want. It really depends according to your needs. And just for the sake of simplicity, let's see, let's add a name. So I'm going to use Plastics Paralus in the region EU West 1. Let's go for the default security group, and these subnets. The image, I'm going to use Ubuntu with a T2 medium, 3 nodes, and 16 gigabyte of storage. So keep in mind that right now, what's going to happen under the curtains. So we are creating a cloud formation. This cloud formation is creating an autoscaling group. And in the autoscaling group, we are injecting the kubeadm token that is used to allow the EC2 instance to join this tenant control plane. Keep in mind that everything is public here because the endpoint is public. In fact, if I issue netcat in scan mode and verbose this IP, you see that I can access it. So in the end, we got a public IP, and the virtual machines here on AWS, once they are provisioned, they will join the control plane as regular nodes. We just need now a few minutes, and I don't know, Saim, if you have any questions so far, because we have to wait. You know, I was too much quick with Kamaji, but now AWS is too much slow.
Yes, absolutely. I think the one thing I really like about is how the control plane upgrading works, because this is not an easy task. You can manage. There are 4 components in the control plane in there. There is etcd, kube scheduler, kube API, controller manager. Then we have custom resources in there as well. Then we have a kube DNS and all these kind of entries in there. It's not an easy task for us. But I wanted interested to learn that, let's say, if you have a control plane running right now, let's say you have a control plane running, and then you can add, let's say, EKS cluster node, let's say that the nodes from EKS cluster that is outside of it. Can Kamaji do these kind of stuff as well? Let's say for sometime in some organization, you have already existing worker nodes available.
Well, it's really challenging. I'm not saying that you cannot, because everything is doable, but it can take some work, obviously, because it means that you have to migrate all the data from EKS to Kamaji and also to update the certificates. Keep in mind that we are working on a CLI because unfortunately you need to get something imperative in that approach where you can migrate the data from any regular Kubernetes cluster from EKS to Kamaji. So yeah, absolutely.
Yes, absolutely. And then that's so how I think the currently is work is where you bring in the control plane first, and then you add node on top of it. And let's
Yes,
see if you have a nodes available to in various reasons. Let's say you have to kill off the control plane, then the nodes are also shut down, or they still be there.
they still be there. Keep in mind that essentially with Kamaji, essentially we are saying we are just taking care of the control plane. Then the node life cycle is outside of its scope because it's really opinionated. You can use CloudFormation, but we saw organizations that are using Terraform, are using Ansible. So in the end, we don't want to. We just want to make Kamaji pluggable to any organization according to their needs. Right now, for example, we are working with the community to satisfy the contracts required by Cluster API. So essentially with Cluster API, you can define the control plane as a Kamaji one, and then you can bring the worker nodes from OpenStack, for example. But it's a long story because also Cluster API, the underlying providers, they need some customization. But we are working with the community. Keep in mind that Kamaji is an open source project, although it's under the umbrella of Classics. But our plan is to donate to the CNCF as a project once we got a huge user base and contributions.
Yes, and one final question. Let's say if you have a control plane already available and the worker node you might want K3s or some local cluster to be a worker node. So can you
You can
do that?
virtual machines on remote data centers. Yeah, they works. Not like a Key3s because Key3s is
Okay.
really opinionated. But yeah, you need to use the vanilla Kubernetes here. We don't want to place any distribution. We want to be totally neutral according to the various distributions. Obviously, keep in mind that if we are going to have K3s or K0 people saying we want to contribute to Kamaji, we will be really delighted. But yeah,
Okay.
keep in mind that we are just addressing to the vanilla. Anyway,
Yeah.
as you can see here, now we got nodes. So what we have to do is to use always our kubeconfig here, and we see that we got the nodes, kubectl get nodes, and now we have to install our CNI. So I'm going to install Calico. So I already have all the command from my history. So I'm installing Calico. And as you can see here, in a matter of seconds, we should be able to see all the pods up and running. So Core DNS, Keep Proxy, these are add-ons managed by Kamaji. So it means that if I try to remove the Keep Proxy DNS daemon set or the Core DNS deployment, Kamaji is aware of that and will reinstall it back, as you would expect on any managed Kubernetes service. And as you can see here, we are getting all our pods deployed. We need just to wait. You need, well, oh my gosh, it's a long day for me. We need just to wait all the pods for being up and running. But in the meanwhile, let's try to see what I have on Paralus. So in the same cluster where I'm running Kamaji, I decided to install Paralus. Why that? Because you can imagine that I got multiple clusters and I don't want to configure for each cluster the Active Directory integration, so on and so forth, but rather I would like to have a single entry point, mostly for a lot of reasons. Firstly, for the audit purposes. So I need to know the developer or the service account that accessed that cluster. So I need a single entry point because otherwise, ending with thousands of clusters, it means that I have to collect a lot of data, and this data, they must be redirected to a log systems. And instead, with Paralus, we got this sort of bastion where I can register all the clusters. Keep in mind that right now, I already created a project that is named Classics, And in classics, as you can see here, I already created 3 tenant control planes where I deployed the Paralus agent or Paralus relay server. Now, since we got a new cluster, what I have to do is to import a new one. So I'm clicking here, saying, okay, it is in the public cloud, and I'll name it Paralus. I can configure some stuff. Keep in mind that you're the expert here, but I'm not trying to steal your job, don't worry. So now I have to download this Bootstrap YAML. And since I'm here with my cluster, with my nodes that are already in ready state, what I have to do is to apply the manifest that is in downloads, and it should be Paralus. Oops, no, not this file, but Paralus Bootstrap. So you know better than me. A set of namespaces and resources are created, and now we just need to wait for the agent to register. And yeah, it was a matter of seconds. And now, as you can see here, I got my fleet of clusters managed by Kamaji. So a provisioning that was a matter of seconds. And I can download a kubeconfig, as you can see here. And what I can do is to say, let's export this kubeconfig. So it was on downloads, and oops, export kubeconfig downloads, and it was, I don't remember the name, kubeconfig. So kubeconfig admin at Paralus local at YAML. And as you can see here, using kubectx, I can change the context of all my clusters. So that Paralus, production, and QA. And what I can do is to access in the production, kubectl get nodes, and you see here, it should work. Yes, it took some time, but I got my nodes, and I can change the context, switch to the less created one, Paralus, kubectl get nodes, and as you can see here, we should be able to see the nodes that were created a few minutes ago. So essentially, it's great because if I try to open Excalibur, I really love these kind of tools. So we're ending up with this management cluster where we could have Kamaji providing control plane. And then we could have Paralus that is providing all the RBAC and auditing features offered by itself. And in the end, we don't need to know the underlying clusters here. So we could have cluster 1, 2, 3. This cluster could be maybe private cluster. So we could have a sort of VPN or maybe something that is saying you cannot access this. So we are ending up with Paralus that, thanks to its entry point, we can have a kubectl, kubectl, or maybe users that are entitled to use some clusters, and these calls are redirected to the right cluster. So cluster 1, cluster 2, or cluster 3. So essentially, I see a huge benefit here because we are simplifying the management of the control planes, and at the same time, we are simplifying also the access and the security with the RBAC features offered by Paralus. And I think that's all. I left some slides here. I forgot the demo slide, but yeah, that's the phase for the QA, or maybe for a quick chat, you and me.
Yes, absolutely. Absolutely. Anybody watching us or listening to me, this is your time to share your question as well. But I think what you reflected. So let's say, I think if we talk about the way Kubernetes works today, is actually, we all know there are two very, very major pains in Kubernetes. Number one is upgrading of Kubernetes control plane and worker node components. Together, you combine these components, and these are 7 of them. And the way Kubernetes interact with control and worker node is quite challenging. And then Kubernetes has 3 releases every year, meaning that you have to update your control plane component to reflect the newest Kubernetes release every 6 months or 3 months from now. So number one, you need a tool to have the centralizability of upgradation of your control plane component. That's where Kamaji fits in. The next is problem is where we have 10 or hundreds of developers working on a team and they accessing Kubernetes cluster. And if you don't give a centralized visible solution, meaning you can give them a token or Bastion hosting or VPN, this is quite, you can do that. It's not no actually harm in it, but scalability is a huge problem. If your cluster is 10 to hundreds and everybody accessing the cluster, you need to access the token, and then you have revoking a permission as well because your team members actually go away from your projects within a future in near future. So that is where the problem is. But that is actually Dario give us a wonderful visibility of how this interaction combines. I think the one thing I like about its Kamaji is we have control plane components. We can bring them up because these control plane components have the brain behind Kubernetes, how Kubernetes work. So brain is hand of Kamaji. So you don't need to worry about brain of Kubernetes. You just need to about your developers just need to worry about the apps that deploy on the worker node. So that is the one good thing is. But there are some cool use cases in here. Let's say if people are working and their control plane actually have some kind of CI/CD pipelining, these cluster eventually, let's say they're using some kind of tooling or GitOps methodology that the cluster is actually the whole cluster is bring up by GitOps controller. Is they actually you write your all the manifest in the GitHub repository. In that case, let's say the GitOps controller Argo CD is Flux managing the entire fleet of the Kubernetes control plane plus worker node. How Kamaji actually will Kamaji look into the Git repository or Git repository actually look at the Kamaji to bring the control plane up?
As I said before, keep in mind that the control plane definition is essentially a manifest. So you can use whatever you want. You can use Flux CD, you can use Argo CD. So essentially, you're ending up with kubectl apply -f as set of manifests. The real challenge, is to deploy applications here. So I want to be sure that I got for each cluster maybe a set of applications. So maybe application 1, application 2, maybe for this other cluster, another set of application, and so on and so forth. So keep in mind that we are working with Flux CD, and essentially with Flux CD, you could have another component here. And with Flux CD, there is a nice feature that allows to deploy some manifests on remote clusters. So you don't need to deploy just in the management cluster, but you can deploy even to remote clusters by specifying a kubeconfig. So for each control plane that Kamaji creates, a valid kubeconfig is available and can be used by Flux CD. And you're ending up with Flux CD that is creating the control planes, and then Flux CD that is pushing the applications to the workload clusters, if we have to use that term. So in the end, you're ending up with automation over automation. And essentially, we don't want to reinvent the wheel because we see that the community is really addicted to these tools that are solving problems. But what I really love is the fact that when you see a project, an open source project that can be used in combination with others, as you can see here with Kamaji, Paralus, and even FluxD, it means that you're enabling developers and also site reliability engineers to do their own jobs. So it's absolutely outstanding and stunning also, because it means that we can build something really, really not so cool, but really helpful for our peeps, so developers and sysadmins and so on and so forth.
Yes, absolutely, absolutely. I really like about this approach potentially is because GitOps is a way people are actually managing clusters, application, everything. Because Kubernetes, we all know, everything is a manifest, is a pod, deployment, replica set, control plane components, worker node components, CRDs, everything is actually essentially a manifest. And these manifest has a single source of truth is Git, and Git has controllers that's called, let's say, GitHub Flux and Argo CD. and you want them to, these controllers can actually look at the cluster and manage the life cycle and the reconciliation of updation of how things actually work. So that's particularly a very wonderful flow to work with. So it's meaning like, if you are a developer like me, if I am actually deploying my application, I need to install Kubernetes cluster first. So number one is Kamaji took charge of control plane component, and you bring your worker node up, and then you install your application on top of it. Next day, you need a GitOps controller to reconciliation of your desire and actual state. You can bring those up, work with Flux CD the way you wanted, and the flow is eventually happening. You don't need to do anything else on your end as well. Plus, then you actually growing in number of team. Like you have two developers now, you become in a 4 or 5 developer join the team. Then the access management become a challenge. For that, you use Paralus project that essentially have a one centralized visibility of all the cluster, and the revoking a permission is just a click of the button. So it's so nitty and is a paradise place to be in, essentially is. But before I let you go, we will definitely explore capsule again in the near future as well. But before I let you go, one final might be the advanced question, might be not suitable in the discussion, but I see there's a need for the Kubernetes API server is now become a universal control plane. There are tools who actually creating databases in Kubernetes. You can actually write Kubernetes APIs manifest to create databases like RDS on AWS, on Azure, or Google Cloud. For that environment, when the Kubernetes API server, the control plane component is creating databases and outside of the cluster, and we are actually managing or took charge of a control plane component. Now, how the responsibility will look like? Will we eventually become responsible for how Kubernetes API server interacting with AWS, Azure, GCP, or they actually responsible, or their APIs are responsible for interacting with our control plane?
It's really a challenging question. So, a final question that is like the final boss in the video games. You know what? I got just my take, also because I've been a site availability engineer, so I was doing this kind of stuff. And what's really cool about Kubernetes is the fact that you can create distributed systems easily. So not just deploying applications, but rather you can orchestrate also external resources. And there is the event loop pattern. So essentially, I'm always fed by events that are coming from objects inside of the cluster, or maybe pushed by the cloud provider. So my take, and if you think about also about crossplane, that is the project that has been created mostly by app-bound people. You're ending up with Kubernetes, that is the centralized API management for all your resources. And I don't see anything bad, but obviously it's more a matter of responsibility. So platform engineering here is trying to solve that dilemma, because who's responsible? Who's writing the operator? Who's responsible for the interaction with AWS, Azure, and so on and so forth? So I'm not saying that platform engineering is a set of tools. No, absolutely. But rather, with platform engineering, we are defining new roles. We are defining new methodologies. So in the end, with that said, I'm pretty sure that Kubernetes is going to play a huge role here. You can think also about not just about creating databases, Kubernetes control planes as doing Kamaji, but let's try also to think about Mercedes-Benz Daimler. They were end users about the latest KubeCon in Europe. And you know what? Essentially, they are running Kubernetes at scale. And if you think about each car they are developing, each car is running software, and this software must be also connected to the internet. So we could end up maybe in the future also with Kubernetes running as a sort of virtual kubelet, who knows, inside of each Mercedes-Benz car. So In the end, I think that there was a sort of statement saying software is eating the world. But now I would say that Kubernetes API concept is eating the world. So brace yourselves.
Absolutely. You nailed it, Dario. Wonderful explanation. Absolutely. Perfect, perfect, perfect. So, with that, we'll take much of your time. And I really enjoyed the discussion, Dario. Everything you explained, everything you shared. I really love the way you actually demoing some kind of when you demo some kind of concept. It's very enjoying when it's a hands-on demo deep dive style. But concepts are tough, but you made it look very simple. So I think if you are a beginner or if you're working for the CK, CKAD exams, check out Kamaji. You can learn how control plane components upgrade, because that's a part of the CK's Kubernetes certification curriculum courses. So there are various ways to interact with these projects as well. But definitely, it's a this is a neaty integration between different open source projects. I really like open source project that combine with other projects to come to solve a bigger umbrella. That's we look at today. We look at the Kamaji, how it's actually interact with Paralus, also with the Flux, and how it's actually interact with IDPs in future. That's another whole level of story as well. But once again, thank you very much, Dario. So before I let you go, there are the Kamaji. You can go to this website, kamaji.clastics.io, and learn all about the great things about this project. If you want to contribute, they have a wonderful documentation that you can go through and start contributing. Then there's a GitHub repository where Dario is the most prominent figure. And if you want to see or actually have some bugs reporting, he's the person to hang out. Then we have a use cases on the repository, on the docs as well, where to use it, and a getting started dive as well. And if you want to use Parallels, go to the parallels.io. Here's a GitHub repository, and here's a Twitter handle where we announce new updates as well. And also the Parallels is also on the two clouds, DigitalOcean and AWS Marketplace. You can click and install and enjoy your rest of the life. So before I let you go, let me give a very quick roundup of what we have covered today. We know managing multiple Kubernetes cluster and federating access while maintaining robust Kubernetes practice, RBAC, is a complex task. However, the combination of Kamaji and Paralus offers a comprehensive solution that simplifies cluster management, enhances security, streamline RBAC operations. With Kamaji, Kubernetes-in-Kubernetes approach, and parallel centralized RBAC and authentication capabilities, organization can effectively manage their clusters, achieve audit logging, implement advanced RBAC practices, ultimately leading to improved efficiency, security, and compliance. With that, we will meet again in future. And very, very thank you. A very, very warm thank you and tons of appreciation for Dario for actually participating in the Parallels community call. We'll see you later again, everyone. Have a wonderful day. Stay relaxed, stay safe. Bye bye.
Thanks, Aim. It was